Welcome to Ask and Learn.
In this question, we are given this setup. Bar AB is rotating 4 radians per second clockwise, constant angular velocity. We want to find the angular acceleration of bar BD and bar DE. Okay, so alpha BD and alpha DE. Okay, so to do this, we are going to use relative motion related um, ideas. Okay, so first, we are going to write down the relative position vectors. Okay, so what we want to do is to find, do velocity analysis and then do acceleration analysis. Okay, all related to relative motion ideas. And then using point D, point D will allow us to find omega or alpha BD and alpha DE. Okay. So that's why we need to write down all the relative position vectors first. Okay, so position vector of B relative to A is negative 20 I hat minus 40 J hat inch. Okay, and then D relative to B is equal to 40 I hat inch, and RD relative to E is equal to 20 I hat minus 25 J hat inch. Okay, then we do velocity analysis. Okay, so we have omega AB is minus 4k hat radians per second, and so VB equals to omega AB cross RB relative to A. This is equal to minus 4k hat cross minus 20 I hat minus 40 J hat. This is minus 160 I hat plus 80 J hat inches per second. Then we can calculate VD A to be VB plus omega BD cross RD relative to B. Okay, so this is 160 I hat plus 80 J hat plus omega BD K hat cross 40 I hat. Okay, so you get 160 I hat, negative 160 I hat plus AD plus 40 omega BD J hat. Okay, K cross I gives J hat. Okay, then we can also do, so this is about for the bar BD. Okay, we can also find VD from rotation about point E. So omega DE cross RD slash E. Okay, this is omega DE K hat cross 20 I hat minus 25 J hat. Okay, so this is 25 omega DE I hat plus 20 omega DE J hat. Okay, and so and we see that these two must be equal to each other. Okay, so equating the components. Okay, so for the I hat, we have 25 omega dE equals to negative 160. So this means that omega dE is negative 6.4 radians per second. And then the J hat, we have omega dE equals to 4 plus 2 omega BD. Okay, so this means that omega BD is equal to negative 6.4 minus 4 divided by 2. Okay, and so you get negative 5.2 radians per second. Okay, so just to put down all the angular velocities. Okay, so we have omega AB is equal to negative 4k radians per second. Omega BD is equal to negative 5.2k hertz radians per second. Omega DE is equal to negative 6.4 kHz radians per second. Okay, and then the acceleration, angular acceleration. Okay, we have alpha AB equals to 0, because constant angular velocity. Okay, alpha BD, we just let it be alpha BD, kHz, and then alpha DE equals to alpha DE kHz. Okay, then we repeat the acceleration analysis. Okay, so AB is equal to alpha AB cross RB relative to A minus omega AB square RB relative to A. Okay, so this is minus 16 minus 20 I hat minus 40 J hat. Okay, so this is 20 I hat plus 640 J hat inches per second square. And then for point D, okay, AD is equal to AB plus alpha BD cross RD slash B minus omega BD square RD relative to B. Okay, so this is about bar BD. Okay, then you put in the relevant quantities. Okay, so simplify, this is what you get. Yeah, so just be careful with all the components and the math. Okay, yeah, just do it carefully, everything will be fine. Okay, and then we do the same thing for AD about point E. Okay, so just do the substitution. Okay, and then simplify. Okay, again, these two equations must be equal. Okay, so we can equate the components. Right, so we have for the I component, 25 alpha dE minus 819.2 is equal to negative 761.6, and then alpha dE will be 1 over 25, 819.2 minus 761.6. You get 2.30 radians per second square. And then for the J hat, so this is what you have, 640 plus 40 alpha BD is equal to 20 alpha DE plus 1024. So alpha BD is equal to 1 over 4D, 20 times 2.304 plus 10 plus 384. Okay, and you get 10.75 radians per second square. Okay, so here are the answers. Okay, so the two rods, BD and DE, they have these angular accelerations in the counterclockwise direction. Okay, and that's all.